My name is Anirudh and today I'll be explaining this code of sound classification by using machine learning. First of all, I have imported some essential libraries such as pandas to read or generate a CSV file, libros library to read the sound signal and find out the sample rate and data, and the matplotlib library to display any of the sample signal. Here I have taken a random sample signal dog bar, of which I'll generate a wave plot later on, and this is the CSV file of metadata which I will be using to train the data, and this is the count of records in each class. Will basically allow me to see the distribution of samples, distributions of the data in the respective classes, like how many samples are there in each class. Then this is the MFCCS, which is a mel frequencies substrum, which will allow me to identify the features of the classification. So here I have used a feature extractor file which will be used to extract the features of the data and data set. And here uh, this is the model ANN model, which contains the input layer, three intermediate layers, and the final output layer. This activation has been done using ReLU, and the final layer activation has been done by using softmax. Uh, Now I'll be training the model using TensorFlow, uh, and yes, I'll be running this code now. It might take a while, so I'll skip the video. Okay, so as we can see, the training is now being complete, and the number of epochs I've given for training is 100, and batch size is 32. So here we have got the finally the loss is 95.58, accuracy of 68.38%, and validation loss is 78.25%, and validation accuracy is 75.27. So here I had given the input file for testing, and it was some background noise of children playing, so it has identified correctly that that this is the sound of children playing. Here we can see some plot. So first of all, this is the count of records in each class. So it has shown me the distribution of various audio files in the classes. Like for a dog bar, I have 1000 files. For children playing, I have 1000 files. For car horn, I have 400 files, and so on. Here I have a plot of training and validation loss, uh, which has plotted of loss against the epochs, number of epochs, and this is the training and validation accuracy plot. And here this is the confusion matrix. For this, the code I have used here for the confusion matrix. Thank you. Hello everyone, my name is Anirudh Dikshit, and today I'll be explaining this code for extraction of features for vibration dataset classification, and this is the program which I have used. Here are the libraries, essential libraries that I have imported, and the dataset here I have used is IMS Rexnord bearing dataset, NASA dataset. This is, and this dataset has test to failure experiment data. Each data consists of individual files that are like 1 second vibration signals recorded at very specific intervals, and the CSV for every dataset I have generated separately for test, like for test 1 bearing 1, test 1 bearing 2 dataset, then test 1 bearing 3, and so on for all the three sets, and I have generated a separate CSV files for them. So here we can see that I have done the dimensionality reduction, the model creation, and then I have used this code for generation of confusion matrix. So I'll go further and play this code, run this code. Okay, so here as we can see, we have generated different scatter plots which show us the normal, outer rays and inner rays and other element. Okay, so here as we can see that I have generated the code for test 1 data, uh, and these are the plots that I have got. It was given in the plot in the question that the at the end of the test to failure experiment, inner race defect occurred in bearing 3 and roller element defect in bearing 4. So here we can see that in bearing 3 we are getting a spike at the end of the test, and for bearing 4 also we are getting the end of the uh, at the end we are getting the spike. This was the maximum function, maximum versus the date and time. Similarly for minimum also, here we can see that we are getting a spike in bearing number 4 and bearing number 3, which was the uh, given defect. Mean function, in this mean function we are getting only a slight spike at the end of the test. See that I have generated a confusion matrix. Thank you.